Probably software development is the only field where we keep on using other softwares, tools, libraries, and databases without actually knowing how they do what they do. And with the arrival of AI, things are getting worse day by day. Not saying that you need those things for learning, but if you want to go beyond hello world application, if you want to create a production grade application where resource utilization and performance matters, where you want to take the competitive advantage of the software or the tools or the database you are using, I'm sure you agree with me that you need to know about the things, how they do, what they do. Imagine working with a database without knowing how the indexing works, what are the options of indexing, how the sharding happens, how the replication happens, and many other things about databases. Vector databases are one such things about which people have limited knowledge on how it works. And in today's world, most of the AI use cases like RAG or Similarity Search makes use of vector databases. I have recently created a small vector database based on my own specific use case, and as a result of that, I can tell you about the vector database in the simplest possible terms so that it's easy for you to understand how it works. Welcome everyone to this particular video where I'm gonna show you how vector databases works without using any third-party libraries barring one thing, which is Facebook AI Similarity Search. It's a vector search database, and I have used this database to prove to you that whatever I am telling about the vector database is correct. So let's go ahead and see the code. So I'm just importing Pandas, Numpy, and Facebook AI Similarity Search. Now, I'm also including sentence transformer, but don't worry, I'm not gonna make use of that. I am using sentence transformer only and only to prove that whatever I told you about vectors is actually correct, and I can show my examples with the logic I will give you and as well as by the encodings generated by sentence transformer. Okay, so initially I'm not gonna make use of sentence transformer. Let's talk about what's a vector first. There are many definitions of it, but I have a single one-line definition. Vector is a multi-dimensional numerical representation of everything. Text, image, you name it. And vector databases are the databases which store these numerical representations. To explain it in a simplest possible way, I have created a very simple data set. As you can see in your screen, like I have 5 lines, 2 words, alphabets A A B B C C D D N E E. Okay, this is the simplest possible data set one can create to explain you the vector databases. And now I'm creating a data frame out of it, and you can see my data frame over here, no surprises there. Now, if I want to store this particular data in a vector database, I need to convert my text, which is an alphabet A to E, into a numerical format known as vectors. Now, if you have seen the usage of vector databases anywhere, especially with respect to the text, you must have seen that people are using one model, pre-trained model, to convert the text into numerical format. And one of the pre-trained model is sequence transformer. You can use different models. Okay, this is one of the model which is being used widely for short text formats. And if you want to encode any text, it will create an encoding sample which consists of 384 numerical values, which is also called the dimension of the vector. Okay, and if you see this, you will see 384 numerical values representing AA. Okay, now just to clarify, any text you pass over here, for example, this is a test, it will generate the same 384 numbers. Of course, the numbers will be different, but it will generate based on its dimension. Okay, you can also make use of higher dimension vectors from Google, OpenAI, or even from Amazon, and you will get more dimension. But For the simplest possible example, what we are talking about here, 384 is much bigger than what we can expect. And these numbers are called vector embeddings. The numerical representation of the text, image, or anything is called vector embeddings. Now, this is the place where people stop worrying about vector databases. They generally feel that, okay, I have a text or image, I have a model, it generates into some numbers. That's all, my work is done. Okay. But have you ever thought that embeddings are number and we can also generate our own embeddings? How? To answer that, we need to first understand what are embeddings. You can see the definition over here. Embeddings are just arrangement of numbers in a way which can identify a pattern. Remember, the word pattern is extremely important. Arrangement of numbers which can identify a pattern. And the example I have given to you, AA to EE, I will use a 5 by 3 matrix to create the pattern. So here is how I am creating the pattern. So for AA, I have created 5 by 3 matrix. You can see it over here. The first row belongs to A. The second row belongs to B, third row belongs to C, fourth row belongs to D, and fifth row belongs to E. Okay. Now since I have 2A, I have given 2, 1. Similarly, 2, 1 for 2B, 2, 1 for 2C, and so on. So this is a pattern I have created where I have a 5 by 3 matrix and each row belongs to alphabet A to E in sequence form. Let's use this particular pattern which I have created to create a vector database. Okay, so this is just to show how the embedding will look like. Now, to use the embeddings in the vector database, you need to flatten each and every row. So what I will do is that I will flatten the vector. I will get this particular representation. Okay, and you can see the shape is 5 into 15 and the dimension is 15. So we have moved from 384 to 15 dimension because our data set is very small and 15 dimension should be good enough to understand this. Okay. Now let's create a vector using Facebook AI Similarity Search, okay, of a particular dimension. Now once you create a vector, you need to specify the dimension. Now what this particular function does, we are not going to get into detail, but this function creates a vector which is a brute force comparison type, which means when I am searching a vector, it is going to compare with all existing vectors and will give me a score with respect to all of them. Okay. And I have added this particular vector which I have created into the vector database. Now the vector embeddings are created and can be used for similarity search. Now let's search for single A. Remember, I have created vector for double A, double B, double C, double D, and double E. So let's create a vector for searching single A. Now I cannot search a text, right? I need to convert the text into a vector embedding. Embedding means in a particular pattern. So if I have to search A, I have to change first row because first row belongs to A. I have put single one over here, right? So this is my embedding of the search. And search vector also needs to be flattened because this is the way search is performed or the storage is kept in the vector database. Okay. Now when we are searching, we give one parameter called k. K means how many nearest vector items I need to get. You can have one, which means only the one nearest. 2, 3, 4, you can get 2, 3, 4 nearest. Okay. Distance is, what is the distance from the search vector? 0 means it's matching exactly, and any number above than 0 means it is keep on increasing the distance. Okay. And position is which index I'm gonna get these numbers. Okay. So you can see distance and position. The lowest distance is 1 at index 0, and if we see the nearest text, we will see AA. And boom, we ended up creating our own embedding for vector storage and vector search, and which is not 384 dimension. It's just 15 dimension. How does it matter? Because vector storage retrieval search is a CPU intensive job or GPU intensive job, right? If you have a small data set, you can very well make use of lower dimension. I have pretty much created a small vector database over here. Okay, so let's go ahead and search k is equal to 1 here and see, it should give me just a, and I got a. Okay, and the distance is 1.0. Now I have searched a single a instead of double a, but what I have stored in the vector double a. Let's search for double b. Similarly, I need to create a vector for double b. You know that the second row belongs to b and it's 2b, so I put 1 and 1 over here, creating a search vector, getting the distance, and you can see here distance is 0.0, which means exact match at the index 1, and if you see the nearest text you will get bb. Okay, so this is how the vector embedding and vector search works. I have used Facebook AI Similarity Search because if I would have used my own vector database, the implementation, you would have said that, it's my own implementation and I am searching it. No, here I have used my own embedding patterns, remember? And I can use the same in my own database, this Facebook AI Similarity Search database, or any other database, any other vector database across the world. Okay. Now, let's try to do the same thing using sequence transformers, just to show you that, okay, whatever I did is the similar thing done by sequence transformer also, but at a higher dimension. I've created the model, I've created the embeddings. Here is how the embeddings will look like. You can see 384 data will be there, and this is my embedding. The shape will be 384, and I've created a new vector by encoding the data, and the shape will be 5 into 384, which means for every text A, there will be 384 numerical values, and this is the dimension. I again created the vector index database and I have added the vector in that vector index DB. The vector is created using sequence transformer. Now let's search the text CC. Okay, so what we will do, we need to convert CC into the particular embeddings. Remember, it's not possible to create vector embeddings for storage using different model and search using different model. Remember pattern. It reads a particular text and generate a particular pattern. Okay, so I'm again generating the pattern for it, and I'm doing the nearest search, and nearest text you can see CC is there, and the distance is 0. Nearest is then BB, the distance is 0.96. I can do the same thing for, single A also. Let's search single A, and let me come down over here. Yes, you can see AA is the nearest search, okay, and the distance is 0.83916. And as you can see, closer to 0 is near, more than that it's far from the search text. Okay, so this is the whole concept of vector databases. I hope you understood it. What is the meaning of vector database? What are embeddings and how to make use of those embeddings? And I do believe that after seeing this video, you will be able to take a better decision about using or not using, or using any specific vector databases. Thank you everyone. Thank you for watching. We will meet again. Until the next time we meet, good day, goodbye. You take care.